Okay, let's do a little bit more here. We have done, I don't know, whatever it was, 3 problems, 4 problems, something like that. This guy right here, we've got to find the side length, right? To find the area, we're going to need 1/2 perimeter times the apothem, right? Or apothem times perimeter, doesn't matter. We got the apothem already. So I go 1/2. I really just need the perimeter, and I'm going to multiply it by the apothem. So what I saw a lot of people do is they put an X right here, and then they drew that in, that radius. And if we had another radius going over to the other vertex, this would be a 60-degree angle because 360 divided by 6 gives you 60. Cut the 60 in half, and you got 30. So this is a 30-degree angle right there. And they said, hey, this is the short leg, and this is the long leg. To go from the long leg to the short leg, we divide by the square root of 3. So 6 divided by the square root of 3 is my X value. So the whole side length would be 12 over square root 3. It's like 2 of those, right? So 2 times 6 over square root 3. 2 is the same thing as 2 over 1. So we take 2 times 6 and we get 12 over square root 3. So that's the side, okay? And so then you got 6 of those. So we're going to take 6 times that amount for the perimeter. The perimeter comes out to be 6 times 12 over square root 3. That would be 72 over square root 3. Okay, and I'm going to put that right here, 72 over square root 3. Some people did tangent. They said the tangent of 30 degrees is equal to x over 6, and then they got x is 6 tangent 30, 6 tangent 30. Then they had to double that, right, to get the whole side, and then they had to take that times 6. So let's take a look at Desmos again here. Let's see. Let's look at Desmos, and let's see how they're really the same thing, okay? So if I go 6 tangent 30 and double it, right? So I got 2 of those, 2 times 6 tangent 30. Now I got to make sure I'm in degree mode, right? This is the tricky part about using tangent. As soon as you start using angles that are in degrees, you got to make sure you're in degree mode. So the whole side is 6.9 something or other. If I go 12 divided by square root 3, 12 divided by SQRT 3, I get the same exact answer. See that? My side length was 12 over square root 3, or 2 of these 6 tangent 30s, right? So we need to take that right there. That's one side. So I take it times 6, and I take half of that, or I could take like half of 6 and put 3, right? So I've done half of the perimeter. Now I'm going to take it times 6 for the apothem, right? So times 6, and I get 124.7. So the area is approximately 124.7, I think. Let's just look one more time, make sure we're rounding to the right decimal, and that's square feet. Okay. Number 4. We had this on a quiz. I don't know if you remember this on the quiz or not, but it came down to this. You draw in an apothem, right? And that's going to split this 6 side into 2 equal parts, 3 and 3. And then when you draw a radius in, you get a 36-degree angle right there. Oh boy, I'm not going to be able to fit that in there. So I'm going to put 36 right out here. That's this angle right there. That makes this angle right here 54, because they have to be complementary with each other. They have to add up to be 90 degrees, right? Now, why do I like the 54-degree angle better? Because the apothem is now the opposite leg from 54. So when I set up the tangent of 54, I say a over 3, and I just multiply both sides by 3. I get 3 tangent 54 is equal to the apothem. And then the perimeter is 6 times 5. So I go area of the whole thing would be 1/2 the apothem times 6 times 5, 6 times 5, because there's 5 sides to it, right? And so let's jump over to Desmos and let's do that real quick. If I go, let's clear off some of this stuff. And I get 0.5 times 3 times tangent 54. Now, this is a little tricky because if I don't put this parenthesis here and I put times 6, it'll think I want the tangent of like the 54 times the 6, whatever that comes out to be, 324 degrees. That's not what I want. I want all of this stuff times, I know what 6 times 5 is. That's 30, right? So I might as well just do that in my head. Like I probably wouldn't put 0.5 times 3 there. I would just take half of 3, and that's 1.5, right? Got an itch on my eye. So that's 61.9 something, right? So the whole area is 61.9. Okay, so let's see here, 61.9. But I only want 4/5 of it, because there's 1 here, 1. There's 2, 3. Did I get that right? 3, 4, and 5. I don't want the 5th one. So I want 4/5 of this number. So I'm going to take 4/5 of 61.9. Some people find it easier to find the area of one of the triangles and multiply it by 4. That would do it too, right? So I jump back over here and I want to put a 4/5 somewhere. I could put it right here, 4 divided by 5 at the end. Now you might think, ooh, the 5's in the denominator. That's okay. It's still multiplying by 4/5. So we get 49.5. I want 49.5 for my answer. 49.5. Notice I didn't do 61.9 times 4/5. You notice that? I took 4/5 of the whole thing because it's going to be more accurate than taking 4/5 of 61.9. Let's compare the two. Let's see how much different they are. 4/5 times 61.9. Probably not that big a difference. Oh, wait, the 61.9 is in the denominator. 61.9. Okay. It would actually give us the same out to 10th place, right? Where it really comes into play is like when you round some number like that, and then you multiply it by 30, right? It's going to be like, if you're off a little bit and you multiply that by 30, it's going to be off by too much. So not as significant when you're just taking it times 4/5. Okay, I hope I made sense out of that. Let's go on to number 5 here. Let's see if we can get 5 knocked out. Oof, it's a tough one, isn't it? So I put on the board that this length right here is cut off. It's 8. That's the height of the pyramid. And we need the slant height, right? So you draw in an apothem. The apothem is going to be 7. It's going to be half of the side, the base edge length, I should say. So that's 7, that's 8. And then we need the slant height, which goes like right there, right? So there's no reducing 8 and 7. 7 and 8 don't have a common factor. So I'm just going to put down the square root of 8 squared plus 7 squared, okay? And then I'll jump over to Desmos and go square root of 8 squared, square root 8 squared plus 7 squared. And I get about 10.6, right? So this number, slant height, 10.6, and it's in feet, okay? And I'm going to put a little dot over the equal sign. Lateral area is going to be 1/2 the perimeter, so 14 plus 14 plus 14 plus 14 would be 56. That's the perimeter right there. That's 4 14s. And then we're going to take that by this slant height, right? So I'll just put an L right there, because you know what I'm going to do here is I'm just going to put right in front of the slant height 1/2 of 56, which is 28, right? I'll put it down just so you see it. 1/2 of 56. So that would be 28 right there, and then times our slant height. And that comes out to be 297.6. So let's see, where should I write that? 297. I'm going to sneeze. Sorry, folks. Let's see here. I'll put approximately equal to, right? It was exactly this, but now I've rounded it, and so I got to put square feet on that too. It's an area. Base. I need to know what the base is. So that's 14 times 14, because it's a square, right? 14 times 14 is 196, I think. So 196 square feet. And then it wants the surface area. So we go the 297.6, that's my lateral area, plus the 196 number. So this is LA. This is the base. And so I tack on 196 over here. So plus 196. And I get 493.6. So 493.6. Okay. 493.6 square feet. All right. Let's see, what else do we have left of our test prep? We got to do number 8. Oh, 7. Oh my gosh. 7, 8, 9, and 10. I'll make that in video number 3. Okay. 7, 8, 9, and 10. Thanks, folks, for watching the video.